Today, we're going to be going over Rolle's theorem. I'm hoping to give you an intuitive explanation of how Rolle's theorem works. We're not going to get into any deep calculations today, but yeah, let's just have a intuitive understanding of what Rolle's theorem is and what it entails. So, before we read out this theorem, let's just see what some of these things mean. F right here is a function, and then square bracket CD means that C and D are included in this interval, and along with everything in between C and D. In contrast, parentheses CD would mean that C and D are not included. However, all the points in between C and D are included. So let's read out this theorem, and then we'll hopefully get a more intuitive understanding of it afterwards. If f is continuous on interval CD and it's differentiable on CD, and f of c is equal to f of d, then there is at least one number n for which f prime of n is equal to 0. So what this means is that if we got these two x values c and d, and then the function is continuous on this interval and differentiable on this interval over here, and assuming that f of c and f of d they got the same y value, so they're at the same height, then there's got to be at least one point in between where we have a slope of 0. This will hopefully become more clear with some pictures, some graphs. So let's look right here. So we see right here, we got C right here, we got D right here, and f is continuous on the interval CD, and it's differentiable on CD. And don't forget, it needs to be continuous on this whole interval and differentiable on this interval. So we got f of c right here. I'll write that there, f of c, and over here we have f of d. And they're at the same height, they got the same y value, so f of c is equal to f of d. So there must be at least one number, n, for which f prime of n is equal to 0. So that means that at some point in between we got to have a flat slope. This should make sense because see, if f of c and f of d are the same value, and if I want to go from f of c to f of d, if I go up, I've got to eventually come back down. And that means that at some point in the middle, I must be having a slope of 0. So that would be over here, and that would be f of n, because over here, we got a slope of 0. Take a look at this one here. Again, we have f of c, f of d. They got the same y value, so they're at the same height. If I want to go from f of c to f of d, and if I go down, eventually I got to come back up. And that means that there must be some sort of transition point in which I'm completely flat, so I'm neither going up nor going down. So that's right here. F of n would be right here. As you can see, we got a flat slope. Now take a look over here. We got f of c and f of d. As you can see, it's flat everywhere. That means that, yeah, it's flat everywhere, so that means that every point has a derivative of 0 over here. Remember, that our theorem just said that there has to be at least one number n for which f prime of n is 0. There can be more than one such point. As you can see right here, there's more than one such point where we have a flat slope. And finally, take a look at this graph here. So we have a flat slope here, a flat slope here, a flat slope here, flat slope here, flat slope here, 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 here. So yeah, you can see that we got all these flat slopes. And so again, there can be multiple points where the slope is flat. And so yeah, that's really all there is to say about Rolle's theorem. So just remember, if you got these 2 points and they're at the same height, then there's got to be some point, at least one point, there can be more than that, but there has to be at least one point in between, such that we have a slope of 0. And of course, this is assuming that f is continuous on the interval, this interval with square brackets CD, and differentiable on this interval with parentheses CD. I hope that this helped you understand Rolle's theorem better, and yeah, hope to see you back soon.